Hello guys, my name is Victor Koss, and I work for GTXL at DEF CON. You can find us at gtaxl.net or defcon.ew. Today I'm going to be talking about DNS amplification attacks. Now, there are two parts to a DNS amplification attack. There's the reflection part, and there's the amplification part. First off, you must understand what a DNS server is and what its function is. First off, DNS stands for Domain Name Service or Server. Now, what do these DNS servers do? Okay, DNS amplification attack. Well, basically, a DNS server, that's not wanting to come off, looks up domain names. Okay, what's a domain? Well, when you type in your web browser, Google.com, you can't just connect to Google.com. First off, your computer goes out to a domain server, 8.8.8.8. If I knew OpenDNS's IP addresses off the top of my head, I would write them down here too. 4.4.4.4. Basically, what you do is your computer goes out to a DNS server and retrieves the information. It's going to do a DNS query. Okay, it's going to ask that DNS server, hey, what is the IP address of Google.com? Okay, what it's going to do is a FQDN, fully qualified domain name, so you add a dot at the end of com, Google.com dot. Okay, and what this will cause for is a recursion. Okay, recursion means go out of your own directory. Okay, basically means go to the root servers and pull the domain off a global server. Okay, now how this all works is basically your ISP will run their own DNS servers, and by default you use them. Okay, there's better ones such as OpenDNS, Google. I like OpenDNS. Now, these servers are sometimes set up insecurely. Okay, and when you receive responses, these responses can be forged, and they can also be amplified. A simple DNS query is only about 60 bytes, okay? But when you look up Google.com, it's much bigger. Google.com is not just one IP address, it's multiple IP addresses. This is known as a round robin. What this does is it load balances between servers. So when you go to Google.com, it's going to show different IP addresses, such as 6.6.6.6, 7.7.7.7, 8.8.8.8. These are just examples. 4.4.4.4, 5.5.5.5, 3.3.3.3, and you can tell that this is just overwhelming, right? Well, you can tell that one DNS lookup, just an A record for Google.com, you can tell that all these IP addresses is going to make a much larger response. It's going to be larger than 60 bytes. You're probably looking at around 4,000 bytes. So that's like a huge, huge, huge increase. Okay? How is this a huge increase? Well, when you look up a DNS, when you do a DNS lookup, you're sending one simple request. Okay? You're saying, first off, you're connecting to that IP address, that DNS server. Well, you're not really connecting to it because it uses UDP, okay? UDP requires no handshake. Or, not requires, but no handshake. That means that your IP is not verified. Your IP address doesn't get verified by the three-way TCP handshake, SYN, SYNAC, AC. Well, UDP doesn't have a handshake. DNS uses UDP on 53, okay, port 53. Now, let's go into this more. Basically, when you do a DNS lookup, usually your browser is something that will do it, okay? You're basically going to do, you're going to ask for an A record, okay, of Google.com. Okay? And this right here means basically FQDN. Okay? So, this will respond 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. About 12 IP addresses. Okay? This right here is about 60 bytes. Okay? Each one of these is about 20 bytes. Okay? 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 2, 4, 6, 8, 10, 12, 13, 14, you're looking at about maybe, I don't know how many bytes is there. 1, 2, 3, 4, 5, 6, 7, 8. You're looking about maybe 250 bytes, okay? So 60 to 250, you know, 250 divided by 60 equals, shoot, I don't know. Or maybe 60 divided by 250. You're looking at a 24% amp, okay? Well, there's more ways to increase this, okay? The 24% amp means that if you're hitting with, say, 100 megabits in DNS queries, well, you're probably looking at about 2.5 gigabits. Now that is a huge increase, okay? This is where the amplification comes in. And there's other ways to make it even better. A records aren't that big, okay? There's something that's bigger, and this is called a TXT record, okay? A TXT record is basically 255 characters max. Lowercase, capital case, ABCD, you know, letters and numbers, okay? So it can allow A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this can allow A through Z and A through Z. Something like that, okay? You can make this a huge text response. And essentially, that could be quite a few bytes. Let's just put it in perspective. Let's just say 100 bytes, okay? And with one domain, you can add basically as many of these text records as you want. So another one, 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 another one. We're looking at about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're looking at about maybe 1,000 bytes. And we're sending one 60-byte lookup. Okay? So that one 60-byte lookup, basically, gets amplified all the way to 100 bytes. Do you see that big increase? This is where the amp happens. You send a small request, the DNS servers send back a big request. Okay? And this is a huge increase. We're looking at a 60% amp. Now, I've seen amps go all the way up to 80. I've even seen ones go up to 100. There's ways to make this much, much bigger. 60% amp, okay? So that means if you are hitting with, you can even get 1 gigabit upload servers. Let's say you get 1 gigabit server that supports spoofing, okay? That's pretty insane. You would be hitting 60 gigabits worth of bandwidth. And with this 60 gigabit bandwidth, you could take down ISPs. I'm saying you could take down ISPs. These lamps just knock them right out of existence. Now, these DNS amps can't be deadly. Now let me go into this a little. Let me slow down. You're probably like, you're rushing off way too fast. I don't even understand what DNS is. I don't even know what's this text record. Basically, all a DNS server is it's kind of like a telephone book. You know what I'm saying? What is Sally Sue's phone number? Oh, I know Sally Sue's phone number. I'm the phone book. Oh, let me look there for you. Let me see. I don't have it in my local directory. Let me contact the big operator. Big operator. Where can I find Sally Sue's phone number? Oh, it's on nameserver1.he.net. Hi, nameserver1.he.net. What is Sally Sue's phone number? It is 740-397-6598. Okay? And we're like, okay. And that comes all the way back to the DNS server, and the DNS server sends that off to whoever sent it. Now this is where a DNS app happens. Who sent that DNS query? Did you actually send that DNS query? No. That DNS query was spoofed. Okay? Now this is where it comes in spoofed. Spoof / reflection, okay? And then you have the amp. It's amplified because a small DNS query into a big response, and reflection because somebody spoofed that IP address and it's actually getting sent to you. It's being reflected as you, okay? You're the one that sent that, okay? It's on you. So, let's just put this in example. Say I have a secured servers in Phoenix, Arizona. See, I'm going to put this in perspective because I want to piss a few people off. And I have this script called DNS. Okay? DNS. When in reality it's just a modified 50x script. Okay? Basically what this DNS script will do is it will use a raw IP spectrum or some kind of code that will allow you to specify where the packet originated. Okay? So what we'll do is in the IP header it will change the from or the source to the victim's IP address. 198.25.13.5. Okay? So, 198.25.13.5, that's not my secured servers. Okay? That's Bob's Linode. Okay? He didn't send that DNS query. Secured servers did. He just made it look like they sent it. Okay? So, what happens is this packet will get sent. It'll be about 60 bytes, maybe a little bit bigger, maybe a little smaller. Depends on what kind of query you did. It'll go off to the DNS server somewhere. And that DNS server will say, okay, I got your thing. And it will send a crap ton of responses depending on what domain you choose. Okay? Say you choose amp.extronic.net. Okay? Say that domain has a crap ton of crap in it, okay? Well, all that crap ton of crap, being 100 bytes per line, that's about 500 bytes. That's much bigger than the 60 bytes. You're going to see an application, and if you have a bunch of DNS servers doing it at the same time, you are going to see a lot of bandwidth. Okay? Now this is where DNS amplification attacks come into play. We're actually going to show you some of this happening live. You're like, live? How could this be? Well, let me show you a little bit. Okay? What you want to do, if you want to get started with DNS amplification, is you want to scan for open resolvers. What an open resolver is a DNS server that responds to recursive queries from any IP address. Some common ones are Google, Level 3, and OpenDNS. Okay? These are all big boy, open, recursive DNS servers on the internet. But the thing is there's a crap ton more out there. Currently, I have a 1.2 million list. Now, what you want to do, if you want to get started with DNS amplification, just for education purposes, is you want to scan the entire internet, UDP port 53. You want to probe it, see if it responds to UDP, and then do a DNS lookup on it, like an A record, google.com. If it responds, you got it. If it responds with serve fail, you don't got it. I'm trying to make a security video. Security video? Yes.
Oh, am I interrupting?
Yes.
I'm sorry.
Sorry about the interruption. So, you want to test the server to see if you actually get A records back, or IP addresses. Okay? So you want to find a server out there that is running maybe bind, you know, ISC bind. Usually it's bind 9. And then you want to make sure that that DNS server can reply to anybody's IP address. Now, ISPs, they're starting to get smarter, and they're going to lock their DNS servers down to their IP ranges only. That's a good idea. But the thing is you can amplify somebody that uses that service. Say, my target uses Virgin Media, okay? I can add some Virgin Media DNS servers in there and use those to hit them. Because when I spoof the IP address, it's going to show the Virgin Media IP address. See, that doesn't really solve the problem. The problem all lies with spoofing. What you need is egress and ingress spoofing. Okay? Spoof. What is spoofing? Spoofing basically means fake or forged. Okay? Instead of saying my name is Vic, I can say my name is Kyle Rohr. You know? And then I'll be like, hi, my name is Kyle Rohr. I would like to know what you offer. Okay? So when you spoof, basically you're saying that your IP address is your victim's, okay? 7777, okay? So, that's not my real IP address. My real IP address is 8.e.e.8. But you know what? My service provider, they don't know anything about egress filtering, you know, or ingress filtering. They don't know how to do that. They don't have source verification in process. They're like CenturyLink almost, and they're like ESATEL. They're like secured servers. They don't know what they're doing, and you can spoof on them. So, there's some others out there, and I know lots of other hosts you can spoof on. Can't spoof on DigitalOcean. Can't spoof on Linode. Can't spoof on Consolidated. Can't spoof on OVH. I don't think you can. But anyway, if your ISP is not checking for source verification, you can say that your IP address is somebody else. Okay? With UDP, there's no handshake, so it's not going to verify your IP address. So that DNS server gets confused and thinks that you're somebody else, and it will send those responses back to whoever you want to target. Okay? So, you want to find DNS servers that are configured to reply to any IP address, and this is by default. Most DNS servers don't have an ACL in place. Okay? This is by default. So, if you're a DNS admin, you're on a DNS server on a network, you want to implement an ACL, okay? Just say 10.0.0.0/8 is allowed recursion, okay? That's what you want to do. On default, any IP address can do a DNS lookup, and that means usually if your DNS server is binding to a public IP address, anybody on the internet can use your DNS server to say, hey, my IP is 8.8.8.8, when in reality it's 7.7.7.7. It's going to be like, okay, let me look at that. Oh, yep. Let's send that off to 8.8.8.8. And that person just got flooded by your server. And the thing is most DNS servers, they're on business class lines, or they're hosted on servers, VPSs, dedicated servers, stuff like that, or even ISPs. So most DNS servers are on very powerful internet lines. Most, not all. I'll run a DNS server at home, but it's not public, it's a private. It's within my private NAT. But anyway, my Linode has a DNS server, but it's firewalled to certain IP addresses. So, that's how I put that in place. But my Linode has 250 meg up, okay? So with that 250 meg up, that could essentially flood the hell out of somebody with DNS responses, right? So you can use that server to DDoS if it wasn't properly configured, okay? So if you are a provider, you want to basically put in ACLs so only your IP ranges can do DNS lookups. But the real thing, if you're a provider, invest in egress and ingress filtering. Check for source verification. That is a must. Source verification is pretty critical. If you can spoof on your network, there are some concerns. Very major concerns. Okay? If you can spoof on your network, there are major concerns. Now, what you want to do is you want to check basically the entire internet for DNS servers that are public, that aren't hardened down to an ACL, and respond to recursive queries. Recursive means not any records that are on their own DNS server. They say they have to go to the root DNS server, get the domain server from there, connect to that domain server, ask it for records, and then send them off. Okay? That's what recursive is, basically. So you want to find DNS servers that aren't configured properly, that allow recursive queries from any IP address on the internet. Now let's take a look at this in a little better perspective. Right here, we have a server that is scanning the entire internet for DNS servers with recursive queries. First thing it's going to do is it's going to probe each server on UDP port 58. It's going to be like, hey, you're running something here. Is this an open port? Is it firewalled? Is there a service running on here? Can I establish a connection? If it says yes, next thing it will do is it will send a DNS query. Like a record gtxl.net. And then if it replies with serve fail, that means we don't have that in our DNS server, and we're not allowed to give you any recursion. Okay? But if it replies with the IP address of my Linode, that means that server just gave me a DNS record. And that means it has recursion enabled. That means we can use it to DDoS. We can reflect somebody else's IP address, send a small DNS query that will make a big DNS query, and basically DDoS somebody just from that DNS server that's improperly configured. So, how does this all work? Well, most DNS apps won't be using just one DNS server. No. One DNS server, sure. You send some queries. You make that DNS server flood somebody. But no. If you flood from one DNS server, they can easily report that. You want to have maybe 250,000 DNS servers. Improperly configured DNS servers flooding an IP at once. What this causes for is more bandwidth, harder mitigation. It's going to make it harder for you to be able to track down the attack. Because all these IPs are connecting at once. It kind of looks like a botnet, but not really. If you TCP dump it, which I do, you're going to see all those IP addresses in the TCP dump being returned. It's going to look just like a DNS result. You're going to see DNS results from all these servers reflected on you. Okay? And with that, you can try to do a little tuning to figure out what domain was being used, but it won't tell you what server sent those queries, because DNS servers think that you sent it, so they send it to you. Now, most SPI firewalls will track the state, and if they see all these DNS queries come from all these random servers coming inbound, they will be blocked. The thing is they're a lot of bandwidth, so your overhead, you're not going to have a good chance of actually, still having internet. Your line's going to be saturated regardless. But SPI is a solution to that. But won't really fix the problem. Now, let me tell you about some scripts. There are scripts that you can run on a server that is capable of spoofing. It's not really what the server is capable of, it's what your network's capable of, okay? And, basically, the most popular scripts I've seen have been Dr. DNS DOS, a script written by No Petrix, I believe that's his name. He's a really cool guy. He has a better DNSM script that I kind of want to get off of him. There's also 50X. Okay. There's also one called, I think it's RT or something like that. It's like a concept script. It's just to show you that, hey, you can do this, but that's not what the script's written for. It's just to show you that how DNSAMP works. So there's Dr. DNS, there's 50X, there's also SDNS, cough 50X. There's a lot of other scripts that have, there's I Hate Perl. And most DNS scripts are private. There's also 40X. That's an improved Dr. DNS DOS. What other ones can I really think? I can't really think of any other ones off the top of my head. But most of these are are C-coded. You just compile them in GCC, usually pthreads, and you just execute them, and they basically tell you, give me the list of DNS servers, give me the domain you want to use to type a query, and the loop, how many times you want to loop through the list, or the time, and the threads, stuff like that. And if you have a server that's capable of spoofing, and you have decent upload that can query all those servers at once, spinning that spoofed IP header, you're going to see a lot of bandwidth, okay? Now, you want to have a massive DNS list. You just want to have the IP addresses of the DNS servers, the scripts, basically connect to those, send a DNS query with the IP header of your target. The target is going to see a massive response because that domain had a crap ton of A records and a crap ton of text records, stuff like that, which caused more bytes of data to be sent instead of just that, that 60 byte query you sent. The result is like 4,000 byte result, but that's being sent towards your target. Okay. So, hope this cleared things up. And if you have 100 megabits, you could hit a gigabit basically. That's how massive this can be. And you have, there's thousands of DNS servers out there. I see about 20 to 30K per 8 block. But slowly I'm seeing them slow down. They seem to be slowing down quite a bit because DNS servers or ISPs and stuff, they're starting to acknowledge DNS amplification attacks and what can happen if you don't have a proper ACL set. ISPs that allow spoofing. You really need to get your crap together. If you can spoof, there's a lot of harm that can come to it. You can spoof SYN, UDP, stuff like that. Stuff that doesn't require a handshake, verification. SYN, to figure out who is spoofing you, or to find out if your IP address is being spoofed for an attack, you're going to see ACK records, okay, coming from the target, okay. But spoofing is a bad thing in itself. So these are the main DNS AMP scripts. You need a server that can spoof, ESATEL, secured servers, stuff like that. Okay? And the thing is you're going to need some decent upload. Performing on these DNS queries at a given time can take some kind of bandwidth. Okay? I recommend at least 100 megabit upload if you want to hit decent. And to run a scanner to check for recursion. And some of these, they can disable recursion at any time. So run them through mmap and grep them properly with the right regex, and you'll be able to clean up your list. Okay. As far as DNS amplification attacks, they're starting to get common. DNS amplification scripts, it's hard to find decent ones. 50x does randomized IP addresses, PTR records. PTR records aren't really a big response. And some of these PTR records, some IPs don't even have a PTR record, resulting in an NX domain. So instead of hitting around 300 megabit, you're probably hitting around 30 megabit at a given time. So it can go in and out with 50x. Not the best script. As for DNS Dr. DOS, that does A records. Once again, good script, but A records aren't as big as text records. Preferably you want a script that will do any record. So it will resolve the whole thing, resulting in a bigger query. But yeah, DNS application attacks are they're bad. I had a friend, he got hit with them, and he had to get a new router because it was a pretty intense attack. He was getting hit about 10 gigabit, and it's pretty insane what these DNS application attacks can do. Are there a way to find out who did them? No, they're spoofed. The IP addresses aren't spoofed. You can identify it's a DNS application attack because you'll be seeing DNS servers popping up. Those IPs are legit. They come from DNS servers. That's not the spoof part. The spoof part is the request going to the DNS servers. Not the requests that DNS servers are giving you. The requests DNS servers are giving you are legit. Requests the DNS servers are getting from the query are not legit. Okay? So, hope I kind of lectured you about it. There's two parts. There was reflection. Gets spoofed. Reflects it under the target, your IP address. When actually you didn't send those requests, it was just somebody able to spoof. And UDP doesn't require any verification for that because there's no handshake. And there's also an application where you send a simple DNS query to it. It's small, but at DNS server, it comes back with a bunch of A records, text records and stuff for that query. Google.com, they have several servers. Boom. You're getting a big that target's getting a big response from that one DNS server. Just imagine 250,000 DNS servers giving you that big response at once. You're going to see quite a bit of bandwidth, and this will result in a denial of service attack. This is a pretty hectic attack. It is a layer 4 attack. But as far as that, it's pretty insane what DNS application attacks can do. I hope I've helped you, and if you want to learn more about DNS application attacks, I will be writing about it on GTextile Tech later on. I don't know when, but you can find me on the web. You can contact me if you want more information. If you're a hosting provider, if you want me to audit your company, I can do that for a certain price, and also see your other insecurities. For DNS servers, run an ACL, properly configure your DNS server. And if you're getting hit, run a TCP dump on source port 53, and that will give you at least some information. As far as DNS servers, there's probably going to be thousands upon millions of DNS servers connected at once. If it's just one DNS server, report it. But if it's thousands, yeah, there's not really you can do about that kind of attack. You're going to have more bandwidth than the DNS servers and their query they're sending you, which costs a lot of money to have more bandwidth. As far as that is, if you know who's doing an attack, figure out what server, or computer, or whatever, what network they're using the spoof from, and terminate it. Okay. I know EasyTel allows spoofing. I know Secured Servers does. I don't